The recent development cycle has brought forward an exceptional array of highly sophisticated add-ons and critical software updates designed specifically for the Blender ecosystem. From generating massive crowds and enhancing character animation workflows to streamlining rigging systems, lighting techniques, and visual effects, let's explore the profound impact these digital extensions offer for your three-dimensional pipelines. The evaluation begins with the introduction of Icrowds. This highly advanced crowd simulation software allows digital artists to autonomously populate vast architectural spaces with countless independently animated individuals. Engineered by the distinguished developers responsible for the widely utilized iCity framework, the underlying architecture guarantees exceptional performance. Professionals are granted access to 7 highly specialized algorithmic simulation modes, encompassing everything from localized walking patterns to deeply complex citywide artificial intelligence networking. The agents navigate intricate street layouts and simulate organic necessities. Furthermore, the installation package is delivered alongside an expansive library of pre-configured three-dimensional human models, making it incredibly efficient for generating populated city centers.
Progressing forward, the concept of classical animation is significantly modernized through the 3D onion skinning utility. This specific enhancement systematically integrates the historically proven methodology of traditional two-dimensional onion skinning directly into the modern three-dimensional viewport architecture. It renders semi-transparent, ghost-like silhouettes representing character poses captured from immediately preceding and subsequent frames within the timeline. This visual feedback dramatically enhances the precision required when refining microscopic timing adjustments. The underlying engine recalculates translucent structural overlays in real time as the user scrubs across the interface, entirely eliminating the tedious requirement for manual graphical refreshing.
Remaining within the discipline of motion graphics, the Hdri Pro animation library expansion has received a highly significant architectural update. This revision expands the foundational toolkit substantially by delivering an enormous catalog of pre-calculated, professionally structured character animations built explicitly for immediate integration with the core Hdri Pro system. The primary developmental objective is the radical acceleration of professional character pipelines. Animators can construct a mechanical character rig and flawlessly apply highly complex locomotive data within remarkably abbreviated timeframes, bypassing countless hours of arduous manual keyframe positioning. The current iteration comprehensively features 150 anatomically precise human animations.
Focusing on geometric optimization, the Simply Loopy software introduces a highly effective modification utility, primarily engineered to automate the mathematically complex procedure of edge loop decimation. During scenarios where extreme subdivision algorithms have generated topologically excessive amounts of interconnected edge loops, this extension functions as a critical optimization protocol. The software deploys intelligent algorithms designed to systematically dissolve structurally redundant polygonal rings while fiercely maintaining foundational geometric details and critical silhouettes. The mathematical output produces a substantially optimized low-polygon mesh that permanently retains the original volumetric curvature and aesthetic form. Environmental rendering procedures are thoroughly enhanced via the Hdri Sky Pro package. This lighting ecosystem extension focuses specifically on the dynamic generation of highly realistic atmospheric textures and volumetric cloud formations. The system seamlessly integrates a massive repository of high dynamic range imagery directly within the native digital workspace. Lighting technicians are granted the capacity to visually navigate through a highly organized catalog of environmental thumbnails, loading desired atmospheric conditions while retaining absolute control over final output resolutions. Complementing the atmospheric textures, the installation includes an impressive suite of fully volumetric cloud presets, significantly elevating the realism of the final photographic render. Transitioning into interactive environments, the third-person kit fundamentally alters the standard workspace interface by actively simulating the kinematic parameters of modern game development engines. The framework empowers users to actively pilot complex character models in absolute real-time directly within the native viewport. The fundamental package provides a mathematically calculated over-the-shoulder follow camera tracking system alongside immediately accessible locomotive states, encompassing walking routines, running cycles, and calculated jumping actions. Furthermore, highly accurate collision detection algorithms are permanently active, guaranteeing precise architectural interactions, alongside a brilliant feature that dynamically records live navigational movements as permanent keyframes. The highly tedious process of texture data compilation is brilliantly streamlined through the Ezbake framework. Designed as a dedicated automated baking solution, the underlying engine calculates the data points of any three-dimensional mesh utilizing standard principled BSDF material attributes and autonomously generates precisely mapped physically based rendering textures. The extracted image data flawlessly compiles diffuse albedo channels, surface normal vectors, and variable roughness maps. The intelligent compiler permits the strategic merging of highly fragmented material instances into fully unified texture atlases while operating non-destructively, ensuring foundational node configurations remain completely untouched for future modifications. Addressing foundational interface navigation, the Undo Plus framework effectively resolves the limitations associated with standard historical state tracking. The software establishes a fully dedicated memory buffer, specifically monitoring viewport rotational positioning, lateral panning motions, and focal zooming depths. The memory engine flawlessly catalogs absolute camera positioning parameters, permitting the operator to instantly revert the digital viewpoint to previously established focal coordinates, utilizing highly specific custom hotkey bindings. The tracking protocol operates completely silently within the background, employing intelligent timing thresholds to efficiently filter out microscopic, redundant tracking adjustments. The complexities associated with multi-software pipeline integrations are masterfully handled by Blendsync. Operating as a hyper-efficient data transmission bridge, the software entirely optimizes bidirectional asset transfers spanning between the core workspace, the Unreal Engine 5 environment, and the Substance Painter texturing suite. Artists wield the capacity to simultaneously export extensive arrays of static polygonal geometry directly into targeted external rendering engines. The intelligent bridging system automatically generates foundational master material architectural templates within the Unreal Engine infrastructure, functioning as an entirely seamless, single-action data transmission pipeline. The presentation concludes with an analysis of the highly engaging fluid flow simulation framework. This advanced technical add-on introduces intuitive computational mechanics, allowing digital sculptors to dynamically paint physics-based fluid systems directly onto environmental geometry. Predictably, leveraging the immense computational power of advanced geometry node structures, the system completely removes standard caching and baking wait periods. Activating the timeline instantly initiates fully real-time dynamic calculations. Liquid volumes calculate realistic trajectories. Granular physics governing sand particles create physically accurate accumulation mounds, and highly viscous lava flows calculate accurate thermal cooling rates, solidifying into rigid rocky structures as kinetic energy dissipates.